Okay, and here's the distance examples. So what I'm going to do here is I'm going to just draw another diagram again. So I'm going to plot the points on -3, 1 and 3, 7. So 3, 7 is again sort of top right, relatively speaking. We're looking at working out the straight line distance between those points. And we're going to do it by considering the horizontal and vertical distances and using Pythagoras' theorem. Now, this formula kind of looks a little bit scary, or at least I thought so when I started A-level. So I'm just going to think about it in terms of just the geometry first of all. So if I have this diagram here, I'll have a look at my x coordinates. I've gone from -3 to 3. And the difference in those values is 6. It's an increase of 6. And if I do something similar for the y values, 1 and 7, that's also a change of 6. So if I use Pythagoras' theorem, which is a squared plus b squared equals the hypotenuse squared, I'm going to have 6 squared plus 6 squared is h squared. They're both 36. And if I square root it, I'll get my answer. And we can leave our answer like that. If you do type it in on the calculator, it's pretty close to 8.5. And that is my distance for the diagonal along here, root 72. Nice. I will try this again. I'm just going to get rid of that, and I'm going to do it again with the formula, just so you can see how the formula works as well. Said it probably looks worse than it actually is. Oh, that's wonky. Oh my days. Let's try that again. I think I might even use the line. Yeah, I'm going to do that. I don't know, maybe I'll use some magic editing. Oh, I can't be bothered. That's fine. That'll do. All right, so the x values, the x2 and the x1, let's chuck them in. The two x values are 7 and 1. The two x values are 3 and -3, so you do have to be careful here. We're going to get like a double negative in the brackets. That is going to work out as 6 and 6. And we're going to get exact same answer. We're going to get root 72 out. So second distance example, a little bit more going on, mostly because we have to work out the distance 3 times, because we're working at the lengths of each side of the triangle when you take these 3 coordinates and join them together to make a triangle. So triangle, 3 sides. Let's see what happens here. So let's just plot the points roughly where they would go. So A is 3, 4. B is slightly to the left and quite a lot further down at 1, -2. And C is 9, 6. So it's quite a lot further across and it's slightly up. Cool. So let's just join that up and hopefully it won't be too wonky. It's a little bit wonky. Maybe I'll just move my coordinates C. There we go. So roughly speaking, it does look like an isosceles triangle. By far from perfect, but it looks like to me that these sides could be the same length. So I need to work out 3 lengths. I need to work out AB, AC, and BC. And I'm hoping that 2 of the lengths will work out the same. So let's get my square root. Ooh, that's going into the text. Oh dear. It's hard work using this drawing tablet. So the x values for A and B are 3 and 1. The y values are 4 and -2. So if I work that out, I'm going to get 2 for that bit, 6 for that bit. And if I add those results together, 2 squared is 4, 6 squared is 36. That's going to work out as root 40. Now, I'll do the same for AC and BC. I'm hoping that AC is going to be the same length as AB. I'm hoping to get a root 40 out. So let's find out. So AC is going to be 9 take away 3 for the X. It's going to be 6 take away 4 for the Y. And yeah, I think that looks good actually, because we've got a 6, change of 6 there, and a change of 2 there. That's going to be root 40. Awesome. So because it's an isosceles triangle, I just need to show that BC is a different length, something other than root 40. Of course, if it was the same, it would be an equilateral triangle. It doesn't look like it is. So for BC, oh my god, that's the worst square root I've ever seen. I'm keeping it in. It's too late, guys. For the x's, 9 and 1. And for the y's, it's going to be 6 and minus 2. I can see this is going to be different. So I'm going to get 8 and 8. And 64 and 64 is root 128. There we go. So I've worked out the 3 distances. 2 of them are root 40. And 1 of them is root 128. So because 2 distances are the same, AB equals AC, therefore it's a isosceles triangle. Ta-da!